Tra-la-la, whilst we wait. Right, so this was a little project that we were working on for Valentines. Has a custom pose, and that was that as far as the project was concerned, because what we did was created what is essentially a it must be number 6 then. A furniture item. Yeah, so a furniture item. So drop in the reference point again. So furniture item with a very simple animation. And in Blender, this is done using let me find the file. This is done in Blender using, in this particular instance for this furniture item, nodes instead of an armature and skeletons. And the reason for this is that the nodes, which, well, let me just find the furniture. I think it's actually number, is that number 6? So that's one of these has the animation that we created. Just got to find the right file. Where is it? Oh, here it is. Or have we animated? Nope, that's not it. Oh, there we go, that'll do. Excuse me. So what we've done is created a very simple furniture item. So we're using nodes in this particular instance because nodes are much easier to work with than skeletons, because for simple furniture all we need to do is lay down well, we use the furniture file, but all we need to do is use these square wireframe objects and attach our mesh to the node and then export, and we've got a functional item without doing all the other messy stuff that's associated with using armatures and skeletons. So this will give us, we can use nodes and we can create very basic animations with these. In this instance it's just bobbing up and down, but with nodes we can rotate, we can't scale, we can rotate. So if we had this scale rotation, so that's right, so if we then, just for the sake of argument, rotated that around, insert keyframe. So this, if that were the animation, that would export without any issues to FBX using nodes. So you can create furniture items, you can animate your furniture items, but, and this is where it starts to get tricky. So we've got a simple animation now that's going up and down very slowly. But we start to get into areas where you tend to need to think ahead, because in the next step, drop in the reference point again. There's got to be a way of loading these in by default. Whoops, that's the wrong thing. Oh, and it isn't doing the No, it's not doing it. So basically what starts to happen is, let me go to 10. Oops. Well, that'll show what was being done. So what we did was we added an animation to the bike using shape keys. So in Blender, we created a set of shape keys that changed. Which one is that? 19. That changed the shape of the exhaust. There are different versions of that, so that's 19. Let's try that one. Oh, there we go. So what we have is an animation assigned to the mesh using shape keys. So this is the morph equivalent in Blender. This is 3D Studio Max uses morphs. In Blender we use shape keys. So using nodes for your furniture item, we can animate the nodes and they do whatever it is that they're doing, and we can also animate the mesh using shape keys. So at various points in the time frame, the timeline, keyframes are inserted that change the shape of the mesh using the shape keys. And that gives us a sequence. So both of these can be exported without any issue to FBX and that imported into IMVU. Let's go to 8. So what you end up with is a functional furniture item that has animated nodes, so it's the node that's doing the up and down animation, and it's the shape key that's changing the shape of the exhaust. But if you want to do something more complicated, for example, adding, which one was it? So get rid of those, just keep that one open. So that's, we could really do with a way of identifying which file we've got open. So if in create mode we can create these different file names, when you have these open, there isn't really a way of seeing which file you've actually got open. So that would be handy for the new create mode they're apparently working on. So let's just go to 13. So if you wanted to actually then make a furniture item that was a bit more complicated, I did something like this. Nodes are not the way to do it, because I'm not quite sure what's going on from the point of view of how IMVU is pulling it all together, but the issue is that when you do that, and this is the problem with doing that, is that to use nodes and create that as an end result, you end up having to generate a lot of assets within your project. So I think this has got, there are 3 sets of hearts and the bike mesh, so that's 4 meshes. And then each one of these has to have its own morph animation in order to shape itself when it's animating. So that's 6 separate morphs to shape each of the hearts. And for some peculiar reason, even though the sequence is timed more or less as it should be in Blender, when these are exported, the timing is off. So it doesn't matter how many loops there are, how many keyframes, not keyframes, how many, what the loop start and end points are. The timing is never synced up. So it's possible that there is an issue with the way that IMVU is reading multiple meshes being controlled by nodes. So if you were going to do something like this, you would have to think ahead and use a skeleton. Because otherwise, what tends to happen is that on export, the export process, I'm not sure if this is FBX that actually does this or whether it's IMVU interpreting the FBX data, but each object generates a shape key or a morph animation and it duplicates it. So even though the morph animations for each set of hearts is a distinct animated sequence, the export process reads the shape keys and assigns them to everything. And I'm not quite sure why it does that. So it makes making more complex animated items much more difficult to do, because at the end of the day it just comes down to timing, because the way that you would actually do this if this were something for a game, the way that you would actually do this is that there would be a bone or other origin. You might even be able to use the vertex that's actually at the dead center of the pipe intake. That would be an origin point, and you would set up a script so that at each frame it wouldn't be set per frame number in terms of so you wouldn't have a heart appearing every 20 frames. You would have a heart set to appear at frame 20 and then again at frame 40 and so on. And that way you would have essentially it's a particle effect. It would spawn an object wherever that point is on the inside of the exhaust. It would use that as a spawn point or an origin point from which a heart would be generated and plopped into the game, and then its behavior would be controlled by the animation. But to get this to work in IMVU, in order to have 3 sets of hearts, you've got to have, or 3 sets of objects, it just happens to be hearts, you've got to have 3 different, where's the node gone? There it is. 3 different nodes. Each node controls a set of hearts. But the problem is the timing. So for the first set, the timing is pretty much immediate. It goes into action straight away. But the second set has a delay. So there are several frames where nothing is happening. And then the third set has even more of a delay. And it's possible that this is causing an issue exporting for IMVU, because the FBX import process doesn't like frames where nothing is going on. So I suspect that what's happening is it's chopping out these what are essentially null frames, or there's nothing going on, there's null movement. So when the animations are imported into IMVU, with that, how many frames is that? That's 31. So with 31 frames clipped at the beginning of the animation sequence, it basically means that when you set the loop end and loop start points for your morph animation, whoops. So we've got one here. That's for the actual pipes, and that is set so that there are 40 frames. So set at frames 1 and 40 because that loops. But if you do frames 1 and 40 for the third set of hearts, you're actually setting it at a set of frames that don't exist within the sequence, and it messes up the animation. So it doesn't matter what you put the start and end points as. With multiple objects where you have to consider, or with multiple objects with timing concerns, it gets quite tricky and complicated. And this is one of the consequences of using nodes. So the only way that this may work possibly is that you have to use skeletons or an armature. So that is what I'm going to try and do now, right now. So we're going to try this live. Don't know if we'll have enough time to do it. We're going to try it and see what happens. So now let me think. So first things first, we need to drop in a skeleton or an armature. So I want to move the cursor to, we can use the position of the root node as our root for the armature. So cursor to selected, and then add armature single bone. Now these things are always tiny when we use IMVU. Edit mode, select the bone. We'll want to rotate around the cursor on the x-axis because we need to lay the first bone on its flat on its back. And we can expand that, make that bigger, so that we can see it. There we go. Now, how many bones do we need? So we need a bone for the bike. So that's going to be called root. So we rename that root. We need a bone for the bike. So we can either right click the head of the bone, I think that's the head, and then press the E key to extrude a bone upwards. Or just double check those things. Or we can just duplicate the bone that we've already got. So Shift D, that duplicates the bone. Rotate X. We need that one to stand upright just to make it easier to see what we're doing. Move that approximately into position where we need it. Right, so that one's called Heart-o-matic. Just call it bike. Right, move that to a new layer so that we are focusing on just that. That's the M key. Right, so that's the armature, that's the basic armature, but we now need to also, that's the bike. So now that we're using an armature, what we want to do, which is, where's the armature? So just turn that X-ray on. There we go. So that's the vertex group for the bike that's attached to the node. So we need to change this now because we've called this bone just bike. So just double click that, bike, and then just double check that everything's assigned. Okay. And then what we can do with this is armature, then pick the armature and it'll list it. We can even change the name of it there. Oh, hang on, no we can't. So we'll call that, whoops, call that double check this. There we go. Yes, the difference between an armature, the difference between using an armature and using parent, so that would be selecting the objects and then just using Control P, is that the parenting will allow the objects to control each other in object mode, whereas using an armature you can only affect the mesh whilst you're in pose mode. Right, so we need 3 additional bones for the heart. Oh, and we also need a bone for the seat node. So where's the seat node? Okay, so this could get tricky. So I wonder if because what you want to avoid doing is trying to replicate the seat nodes. Let's try it this way. So select the seat node, snap the cursor. So we've got a point of origin. Select the armature, edit mode, duplicate the bone that we've got selected. So Shift D, and then we can snap that. Selection to cursor. So selection to cursor, and this is going to be called Seat 01 Heart-o-matic. C1 Heart-o-bike. And we can do the same for the handle. Duplicate. Selection to cursor. That's going to be handle 01. And then we've got these are the capture and picture nodes. We're going to need to adjust these later because at the moment they're all pointing in a particular direction. So let me just save this file, save as. '21. Because where's the file gone? Let's try that one. Right, yeah, so the nodes for the avatar seat pointing a particular direction. So I'm going to open another instance of Blender so that I've got that there as a reference, because these need to be rotated to match. So they all point backwards apart from the picture. And it's not recommended that this is done because it can mess up the orientation. It can mess up the orientation of the avatar when the avatar appears in the room, using the furniture item. So what we're doing is rotating the bone around the head axis, or the head origin point, or whatever it's called. But because these bones are perpendicular, we know that it is 90 degrees when we rotate it. But these ones will be slightly trickier to do, so that's capture. One dot sitting. No, that's picture. Picture 01 sitting, and that's capture 01 sitting. So rotate it flat first. And then they need to be rotated so that they point at one another. Whoops. That's about right. Because what will happen is that if this is off, so if that one is perpendicular and that one's at an angle, when the avatars appear and they use these spots, one avatar will be facing, well, relative to the screen as we're looking at it now, one will face downwards and the other one will face at an angle towards them. So when they do interactive actions, so shaking hands or what have you, they'll not line up. And that's one of the reasons why you don't want to change the default nodes. That's not, that's slightly out. Oops. Okay, so we've now got seat nodes. So the next thing we need to do is add three bones, I should say. That's 1, 2, and 3, and these are the hearts. So that's smoke 3, smoke 2, and smoke 1. Right, so let's just double check this. So what we want is we need to check the relationships now, because all we've been doing is duplicating bones. So we want handle and seat should be parented to the bike. So when the bike moves, those two bones move. So select the bone, and where's the, oh, there it is. So bike, and again bike. So selecting that and just move. Why hasn't that done that? Okay, that's weird. That's very weird. So let's see what it does in pose mode. Oh, so it is working. It's just that I wonder if the relationships lines is turned off. Oh no, they're there. That's weird. We should see... Oh, there it is. Very faintly. Right, so we also want to do the same thing to the smoke. So smoke, bike, smoke, bike, smoke, bike. Alright, so double check again. That works. Double check that. Right, so we need to link up these two bones with the root. So what that means is that the bike, that controls all the bones that are associated with the bike, but the root then controls everything else. And then we have to, again, bike needs to be connected to root. So, oh, it's rotating around the, that's better. Right, so right, so that's what we've got. Now we need to add the hearts. Now, I wonder which is the best way of doing this. We've got two ways of doing this. I guess it's going to depend on how complicated the end result is, because what we can do, or could do, is we could keep the meshes separate, which makes the project slightly easier to manage, because each of these would have their own heart in IMVU once imported. So there are, oh, those are the actions. So these are the meshes, sorry. So each mesh is completely separate. The problem with that is that it tends to then cause an overproduction of morphs or shape keys, because each shape key, well, however the exporter does what it does, or the importer does what it does when it's converting, the end result or the net result is that we end up with each mesh, because taking a look at these that's the seat. That's the seat. What's that one? That's the bike. Right, so there isn't a separate morph animation XPF file for any of these smoke bubbles. It's all being controlled, I think, by the one that is associated with the bike itself, which you don't actually want, which again may feed into why the morph animations might be messing up, because you can't add, well, you can, but it does, it breaks. It breaks the morph. So there's something weird going on, that when you add a morph on top of a morph, it'll, you know, morphception, it'll overmorph the morph. And that's what should be happening, in the sense that each of these smoke bubbles things should have its own morph animation associated with it. But if you add that to the actual object itself, the end result breaks the overall morph, which is already active because it's applied to something else. So what we may need to do in these instances is is join all the meshes together, which tend to want to try and avoid doing, because it tends to then start making the project complicated in terms of animation and moving things around. But it looks like that's the only way that objects can be safely animated but still controlled within the realms of a single project. So that means getting rid of all of these sequences. Oh no, the morph is really tiny, so do I need to get rid of the... Yeah. Whoops. Oh, I think you have to do that again. I think you have to get rid of the sequence first and then get rid of the morphs. Otherwise, and this isn't too much of a hassle to do because the morphs are relatively straightforward. So get rid of that. Get rid of that. And get rid of that. So we need 3 of these, so let's just make this slightly larger. That way we can have them in the same place, but easy to select. Easier. So that's smoke 1, smoke 2 and smoke 3, so smoke 1, assign, just hide that for now. That's smoke 3, vertex group, smoke 3, assign, hide that for now, and then smoke 2. Okay, so let's save this 21. So there's an inclination to keep these heart objects completely separate, but from experience doing that, it's going to end up in having too many morphs duplication, and of course when that happens it's difficult to determine which one is which. So I suspect sorry about that, a sneezing fit. Best off that the microphone be silenced for those. So that's 3, that's 1, where's 2, there's 2, right, so hide that, let's just join these together and see what happens. So that's Control J, and this should mean that if we've got this done correctly, yes, there we go. So our bone controls smoke, so we can now do that with the other two. So whoops, and hide them. So that's 3, join that, Control J, so whoops, 3 is the tiny one, that's okay. And that should be 2. So we have 3, whoops, and that controls 2. So that's 3. That's 2. And that's, well, that's 3. So the big one is 1, or the first set. Right, okay. Just delete this path. So we don't need those anymore. So we could just move those. Right, so that's the basic skeleton of the bike. So we've got a single mesh that has multiple objects. And each object is controlled by a vertex group. And we can see that in action if, right, so that's face select, so just go through the groups. Select, deselect, select, deselect, select. And then for the bike itself, select, and that only selects the bike, so good. And the bike, well, it won't show in edit mode. The bike has the morph animation assigned to it. And it's still being controlled by so we need to unparent, keep transform. Ah, there we go. So that was still being controlled by the nodes that we'd set up previously. So all of these are now have no influence over the bike. So this could be interesting. Right, so that's the skeleton. So we set it up so that the root bone controls everything. And this in fact could be a node to which the skeleton is parented. So we could still use the root node of a furniture item and then just link a very basic bare bones armature without this bone at the bottom. So if that was not there, so our armature would consist of these bones, because FBX allows us to be able to combine all sorts of things together to create skeletons, which is how we're able to export items from SketchUp, because SketchUp doesn't have nodes, but you can use meshes as proxies, and as long as they're named appropriately, following the naming convention IMVU is expecting, it will export them. So that is our armature. So the root bone controls everything. The bike bone just controls the bits associated with the bike. So that's the seat node, the handle node, and the smoke bones. And then everything is just connected to roots. So save. So I wonder what's the best way to do this? Because we've got a couple of things happening at the same time. So if so let's just get a root position of all the bones. So this is our base position. So we're at frame 1, location rotation. So this gives us our base frame for which to work. Right, so what we need to do is match the smoke bones to the action of the pipes.